Hi, welcome to Digital Electronics. Today I'm going to focus on Boolean Theorem, which is under Chapter 3, Basic and Combinational Logic Circuit. So the outline of Chapter 3 is 3.5 is talking about Boolean Theorem. So in previous class, I have mentioned all the basic gates, and this is the summary. So we have a NOR gate. So when we have a input 0, it will become 1 and 1 becomes 0. We have a gate AND gate. So the input is possible of 4 inputs because 2 inputs will have a 4 possible condition, which is 0 0 0 1 1 0 and 1 1. So for AND gate, 0 0 will have 0, 0 1 will become 0, 1 0 is 0 and 1 1 is 1. For NAND is a reverse of n, so 0 0 0 1 become 1 1 1 0, or become 0 0 become 0 0 1 is like addition. 0 plus 1 is 1, 1 plus 0 is 1 and 1 1 is 1, and NOR is a reverse of OR, 1 0 0 0, and XOR is a special. Whatever the input is not same is become 1. When the input is same, it becomes 0, and XOR is reverse of XNOR is reverse of XOR. So I also talked about the previously I already mentioned about the possible combinational logic circuit. So this one is the example one. So when we have a combinational logic circuit like this with a 2 input, so we're going to have the step 1, and then going to have over here the step 2 is the second gate you'll have over here, and third step is this one. And when you have a Boolean expression, you're going to have a result of this. So and you can generate the truth table by applying each of the possible inputs 0 0 or 0 1 through this particular circuit, and you get the response at X, and you put over here. So you already highlight this in the previous class. So when we have the Boolean expression, when we get it from this particular circuit, this can be very complex and repetitive. So therefore, it is very necessary to be simplified so that we can reduce the number of gate we use and also the operation time, because each of the gate have its own required operation time. So therefore, the higher number of gates will cost you more time to process. So I thought this is the Boolean theorem. So we need to know the rules. So there are few rules, 18 rules. So we started with the most common one, the first rule and second rule under the commutative law. So A plus B is equals to B plus A. So A plus A and B, A plus B or, so is equals to B plus A. And for the rule number 2 is A dot B, A and B equals to B and A. Next, the associative law. So rule number 3, A plus in the bracket B plus C close bracket is equals to A plus B in a bracket plus C. So you can see the circuit. So this is the first one for the red color, response of the red color. This is the response for the green color. And if you have without the bracket, you with the 3 inputs A, B, C, you're going to get the same response over here. Same good for the fourth row. So you're going to, but this one the operation is changed to AND gate. So you're going to have A and B and C over here. So this one is the green one, and this one is the red color, and this one is the blue color. So you're going to have the same output as a result. So for the fifth law, which is the associate law under the 5a, is A dot in the bracket B plus C is equals to A dot B plus A dot C. So it seems like a multiplication. So when you have a multiplication of something bracket with a. So a will go in a times b, that's why you have ab, and a times c, you have ac. So if you draw the circuit, it will look like this, and this one is this one, so you're going to have the same results at the end. So for the 5b, a plus b dot c plus d. So a plus b, you have this result, a and o, and c plus d is this one. When you cumulative together, you get this result. It's also same as a times with c, so that's why you have ac. A times d, you have a ad. B times C, you have a BC, and B times D, you have a BD. So this result is similar to this result of this circuit. So you can compare. This one you have 3 gates, but this one you're going to have 5 gates. So which you require more number of gates. So for the single variable theorem, so you have rule number 6, A double bar is equals to A. Rule number 7, a times 0 is 0. Rule number 8, a times with 1 is a. Rule number 9, a times a is a. Rule number 10, a times a bar is equal to 0. So something times with the alternate of that particular thing, you get a 0. Rule number 11 is a plus 0 is a. Rule number 12 is a plus 1 is 1. So how you're going to prove over here is you're going to, this one is next one for 15. So rule number 13, a plus a is a, and rule number 14 is a plus a bar is 1. Rule number 15, which is the most difficult one, it will be a plus a dot b equals to a. How you're going to prove this one will be, first you factorize the a. So you take out the a outside. So you're going to have a dot in the bracket 1 plus b. By applying the rule number 12, a plus 1 is 1. So you're going to have 1 plus b going to have 1. And by applying the rule number 8 over here, a plus 1 is going to a. So that's why when you times a times with 1, you're going to have a. Rule number 16 will have a plus a bar dot b is equals to a plus b. How are you going to prove this? By using this method. First, you apply the rule number 15. So a is equal, so you have see the rule number 15 is a plus ab is equal to a. So this a you expand to a plus b. So this is rule number 15 plus a bar dot b. So many may ask why this one a is equals to this one, because we want to have this b, because we have a b over here. So later we can factorize the b together. So that's why we need to treat this one using rule number 15. So this particular situation, so when you factorize this a using by rule number 9, you're going to a times a is a, so you're going to this particular a become a dot a, and a dot b become a dot b plus a bar plus b. By applying rule number 10, so in this particular the last one, so a plus a is 1, and a dot b is this one, a bar dot b is this one, and you apply the a over here, because you rule number say that rule number 10 says that a dot a bar is 0, so you just include this a so that we have a factor outside, and then take it out, rule number 14. So by applying the rule number 14, so you're going to have this equation, and last for applying the rule number 8, whatever times with 1 you will get a, and whatever times with 1 again, for here b times 1 will become b, and that's why you have a plus b. So for the rule number 17, De Morgan theorem, one of the very favorite theorem is a plus b bar, the whole thing bar, will equals to, you have to broke the bridge, the big bridge, the top one. So from, but you need to change the operation. So here is or, so it become a bar dot b bar, right? So this is the gate, NOR gate. So you become like this, and then at the end you got again. So you're going to have the similar output if you have this one or use this one. But here, if you see, you only use 2 gate. Over here, you need 1, 2, 3, 3 gates to get this particular results. So rule number 18, this is similar to rule number 17, but however, this is using NOR. So a dot b bar, the whole thing bar, when you break this one, it becomes a bar plus b bar. So similar, so you have this one, and then you got this one, and when you compare the two table, the situation become this. So I just provide you one example. So you have a dot b bar plus c bar dot d. So when you have such a condition, you want to break the big bar over here, the top one, everything so you just need to change. So it become this one, it become a dot b double bar dot c bar dot d bar, everything over here. So we can use the tools to simplify the Boolean expression. So when you have a Boolean expression of a dot b dot c plus a dot b c bar plus a dot b bar c. So first you try to factorize the number 1 and number 3 product, which is a b c. So you just put over here, you have a b bar over here, so you just need to take out the a and c. So you put the a and the c over here, you have a b plus b bar, and then you repeat the a dot b plus b dot c bar. And then by using rule number 14, b plus b bar equals to 1. So over here, b plus b bar equals to 1. Rule number 18, anything times with 1 will become anything. So over here, a dot c times with 1 will have ac, similar to this situation. And rule number 18, b dot c bar is, you use the De Morgan law, and b bar plus c bar, you got this one. So from the this one become this one, and you just expand it, a times b bar and a times c bar, you get this one, multiple. And then later on you factorize it to take out the a. So you have an a over outside, you have a c from this one, and blue from this one, and you factorize this one, c plus c bar. Using rule number 14, it will become 1. So this will become 1. And you use rule number 8, which is some a times with 1 is a. So you're going to a times with 1 is going to a. And use rule number 12, 1 plus b bar equals to 1. So you 1 plus b bar equals to 1, and 1 times 1, a times 1 become a again. So that's why you, when you simplify from here, it become only 1 gate at the end. So this is example number 3. Use a similar rules. So you have a plus b dot in a bracket a plus b bar. So first you use the rule number 5b. You multiple a times a, you come a times a times b bar, you come a times b bar, b times a, you come b times a, and b times b bar, you come this one. And you use by using rule number 9, a times a will become a. So that's why you have a times a become blue a. And then also b times b bar, rule number 10 is 0. So that's why you have a 0 over here. And then you can eliminate the 0. So you're going to have a plus a bar b dot bar plus b dot a. So you factorize the a outside. So you're going to have this situation. And then you use rule number 14, b bar plus b equals to 1. So that's why you have this situation. So you take it out 1. You use rule number 8, a plus 1 equals to a. And last, you get the result a. So this is the example 4. So a bar plus c dot b plus d bar, everything to become a bar, a big bar over here. So usually when you have a situation like this, you will focus the big bar first. So you break it out with the De Morgan law. So you break it out over here. So from here, but you change the operation from multiple to plus. So rule 18, by using the rule 18, you broke the bar become plus, and you have a smaller bar over here and second smaller bar. And then you broke again, you have a bar plus c big bar, so you broke again, so you have double a double bar dot operation change from plus become dot, and you have a c bar. So this is, you have to apply the rule number 8 for twice. That's why you get over here. And similar to this one, b plus d bar big bar become b bar dot d double bar. And then you use rule number 6 twice. Anything double a equals to double bar is a, and d double bar is d. That's why you get a final answer of a dot c bar plus b bar dot d plus d. So this is a self checkup, so you can have a look, practice on this particular one. So it's to ease you up, I do provide some answers, so have a look. And the number 2 is going to be a little challenging, so have a look. So this one is to simplify the circuit using Boolean algebra and redraw the simpler response. So nothing much. Instead of providing you the expression, I change to a circuit. So you have a circuit, a combination. So you have to come out with a Boolean expression of this circuit and then simplify it, and you got the answer. So same for the number 1, number 2, and number 3. So be careful, number 3, little tricky. So yeah, that's the answer for that one. All right, please continue to the document 3.6. Later on, we will cover up the Carnot map approach, which is also known as K-map. That's all. Thank you.